Guys, this is video 1.6. We're going to hopefully review scientific notation for you in this video. You should have had exposure to this in other science classes and math classes, maybe. So we're going to kind of go through this a little bit quickly, kind of review it. It should be something very easy and familiar to you. You'll know and remember scientific notation is just a method for expressing very, very large and small numbers easily. All right, so for example, this is a number that we're going to use all throughout the year. Okay, 6.02 times 10 to the 23rd atoms equals 1 mole. All right, you have no idea what that is. It's okay. In Unit 3 we will talk about it, so don't worry about it right now. But take a look at that number, right? The number is gigantic. If we have to use it multiple times on a problem, we don't want to have to write out 23 zeros every single time. So we use scientific notation as a quick shorthand way to express that large number. Another example right here is the number a million. Okay, this is in standard notation. Okay, standard notation is when it's written out completely. Scientific is where it's in a decimal. The scientific notation of that number would be 1 times 10 to the 6th. All right, so we always have to remember to move the decimal to make the mantissa. You may have never heard this word before. That's just the number that's out in front, okay, between 1 and 9. Okay, so the number out in front needs to be between 1 and 9. It's going to be a decimal a lot of times. Then we will arrange our exponent, which is the number up to the right of the 10, and then we're going to check our work. Always, always, always check your work. All right, you were asked to convert to scientific notation on the regents. That should be a gimme problem. Okay, if we were to take that and we remove the decimal place 6 places to the right, we would get the original number. So for example here, figure out first what numbers are important. What do we want to keep in our mantissa? Okay, the zeros aren't important unless there's numbers in between them. So here, since they're all at the end, we don't care about them. They're just placeholders. So our mantissa, the number out in front, is going to be 1.23, okay, because it's between 1 and 9. Then we're going to multiply it by 10 to some power. To figure out that power, okay, remember that large numbers have a positive exponent, and small numbers, i.e. less than 1, are a negative exponent. Okay? So you're just going to count out how many spaces we had to move the decimal. 1, 2, 3, 4, 5. I'll do it so you guys can see it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this would be 1.23 times 10 to the 11, and that is our scientific notation. All right, where this long number, the longhand way, is called what we call standard notation. Okay, again, this should be a review for you, so my encouragement to you as a review, first couple of days of school, pause this video right now and then go through and try to work these 5 problems out and see if you get the right answers. So this number 1 here, 3.4, is going to be our new mantissa because it's the only important numbers that we're worried about. When we move our decimal, we should find that it's 3.4 times 10 to the 7th power. Number 2, a little bit different. This is a small number, so that's going to tell me right away that, hey, I've got a negative exponent. 6.7 is the mantissa, the number out in front. When I figure out how many spaces I had to move, that's 10 to the minus 6th. Now, number 3, a little bit different. I'm going to star it because every number is important here, but we still need to make sure that we get it in between 1 and 9 as our first number, our mantissa. So to do that would just be 2, and then put a decimal place there in between the 2 and the 5, 2.5864 times 10. It's still a large number, so it's going to be a positive exponent. We should get times 10 to the 4th. Now, opposite way. Given scientific notation, going to standard notation. So it's a positive number, so it should be a gigantic number. I'm going to move my decimal 8 places to the right. So if I did that, it'd be like 1, 2, 3, 4, 5, 6, 7, 8. So I would fill in all those spots with zeros. Okay, and I'm going to rewrite it so I know what it is. So that's going to be 5, 7, 0, 0, 0, 1, 2, 3, 4. 4 more. Okay. You can put commas in there if it helps you organize it, that's fine. Number 5, small, tiny number. I'm going to have 10 zeros out in front. 634 is what we should have. Okay. Now, how we will be using it, you might see a question having you convert between scientific and standard notation, but a lot of our calculations, guys, we will have scientific notation problems because we'll be dealing with small quantities or very large quantities of atoms. Okay, so we got to be able to know how to plug it into the calculator, and that's what I'm going to do for you here. So grab one of my calculators in the classroom because those are what you're going to be using on tests and quizzes. And I want to show you how to properly plug it in. This is a skill that you need to master today so that it doesn't come back to haunt you later on. Make sure you know how to plug in scientific notation numbers into your calculator. So to do that, we're just going to type in the Mantissa first. So with that number that's given to you there at the bottom, 2.3, okay? Now, in math class, they may have had you use the caret key, so times 10 to whatever power. We're not doing that here in this class, okay? These calculators have a specific function that will allow you to tell it that it's scientific notation to keep your order of operations intact. There will be a time, probably for most of you, where you will plug one in, and you think you have it done right, and then you've just plugged it in wrong because you forgot this step. So to do that, like number 4 says, press the EE key. So for me, I know my calculator looks a little bit different. I couldn't find, or they don't have an emulator that looks like yours, but it's in the same location. Hit the second button. Then you're going to hit the button that's above the number 7. So for me, it's a comma. For you, it's like x to the -1 or whatever. When you hit that with the second function, it's going to give you this capital E. What that is doing is telling the calculator that, hey, this is scientific notation. Well, we've plugged in right now. If you look at that number on your note page, we've plugged in 2.3 times 10. Okay, that E means times 10. So the only thing left that we have to type in is the exponent. So our exponent in this problem says -5. Okay, so I'm going to make sure I do that. Then I'm going to hit enter. Okay, and bam, there it is. Now I know that doesn't look anything, but we're going to use it as calculations, like this one that's down here at the bottom. We're going to multiply that number by 1 mole, or that big number that I gave you before. This is where it's vital that you kind of ignore what you've learned in math class and you follow what I'm teaching you. Okay, we're going to use that scientific notation function. So here we go. We're going to multiply by 6.02 second E 23. Now you might think, well, when I multiply, it's going to be fine. I don't need to worry about it. Okay, but we're not only going to be multiplying in this class. We're going to be doing a lot of division as well. And when we start doing this thing called dimensional analysis, which we'll be getting to in a couple of videos, that's where things will get messed up. And you might have beautiful work, but you've plugged in the calculator wrong. The calculator, guys, should never be why you get it incorrect. So when we hit enter, it told the calculator that, hey, we have scientific notation. We're going to multiply these numbers together, and then we're going to report our final answer. So I'm going to go back to my notes, and I'm going to jot that down as well. So our final answer here would be 1.38 times 10 to the 19th. Okay, I'll talk about why I rounded that in the upcoming videos. All right, so that should have been a quick review of scientific notation. You've got practice 5 that you can work on now. Check your answers with me or a partner, as well as the answer key in class. Until next time, I'll see you later.